Hello hackers, welcome to episode 5, Web App Pentesting with Burp Suite and AI. In today's video, we'll see how you can use AI as your personal security research assistant and complete hours of work in just minutes. We'll learn how to analyze Burp Suite traffic using AI to uncover hidden patterns and identify potential vulnerabilities quickly and efficiently. Disclaimer, this content is for educational and ethical cybersecurity purposes only. Always test on systems you own or have explicit permission to assess. Unauthorized access or misuse is illegal. First, we'll see how to set up Burp Suite. Burp Suite comes in both free and paid versions. In today's video, everything I'm going to show you can be done using the Community Edition, the free version. Community Edition is already pre-installed in your Kali Linux by default. There are just a few advanced tasks that are only available in the paid version, but for what we're learning today, the free edition is more than enough. To connect it with your browser, you need to configure the proxy settings. Once the proxy is set up, Burp Suite will be able to capture any request sent from your browser, and you can perform testing on those requests. You can easily install the Firefox add-on Firefox. It's a simple and convenient way to configure your browser so that traffic can be captured directly in Burp Suite without complex manual proxy setup. You need to install the Burp Suite CA certificate. This step is very important. To view and analyze data from HTTPS websites, this certificate must be installed and trusted in your browser. With the proxy already configured in your browser, type the following in the address bar: http://burp. In the top right corner, click the CA certificate button and download the file. Now in Firefox, go to Settings and search for Certificates. Click View Certificates, then Import. Select the downloaded certificate file. Check the box that says Trust this CA to identify websites. Click OK to finish. Once this is done, you'll be able to properly intercept and view HTTPS traffic inside Burp Suite. When Intercept is turned on, every request sent from your browser will be captured and paused here before it reaches the server. Even if Intercept is turned off, the requests will still be recorded automatically. HTTP History tab, where you can review and analyze them later. For testing purposes, we'll use a demo site and capture some traffic from our target application using the Burp proxy. Notice that here we are intercepting request. If forward the request from here, the web page will load normally in the browser. I hope everything has been clear so far. Now let's move on to the main point. I've captured the HTTP requests and responses from the demo site. When testing for vulnerabilities, we usually target parameters first. If parameters are present, the chances of finding a bug are much higher. If you search for anything in the search field, you'll notice that your input is reflected back in the response. The server is returning your input in the response, and from a security perspective, this is very important. Sometimes the parameter appears directly in the search bar URL, and sometimes it shows up in other sections of the response. To find it more easily, go to HTTP History in Burp Suite. You can quickly check whether a request contains parameters. If a parameter is present, you'll see a checkmark indicator next to the request. Once you identify the request you want to test, send it to Repeater to begin further testing. After sending the request to Repeater, what should you do next? First, understand the request. Start by checking. What is the method? Is it GET or POST? Where is the parameter located? Understanding these basics is the first step before performing any proper testing. When we send the request, we can see a normal 200 OK response here. This means the web page has loaded successfully and the request is being processed correctly by the server. To check whether there is a cross-site scripting or SQL injection vulnerability, we can start by adding a single quote at the end of the parameter value. This simple test input helps us observe how the server handles special characters and whether it triggers any errors or unusual behavior. Added the single quote, the application is now showing an error. At this point, copy the full request and response, then give it to the AI and ask it to analyze the behavior. The AI can help you understand whether the error indicates a potential vulnerability and what type of issue might be present. I copied the full request and response, created a structured prompt, and saved it in a file to avoid formatting errors in sgpt. In the prompt, I wrote, Act as a penetration tester, analyze this HTTP request and response, identify SQLi, XSS, and information disclosure, suggest testing steps. Then I added the request first, followed by the response, so the AI could analyze everything with full context. SGPT results are in, and we've identified a potential SQL injection in the system. It looks like the data we're sending is being passed directly into the query without any sanitization, which is exactly what's triggering those backend errors. It also provided the scripts for manual testing. Now I'm going to use the Gemini CLI to see what kind of analysis it provides. I'll copy and paste the same prompt from the saved file. Request and response were analyzed using Gemini CLI. It took a little time to process. Gemini identified a classic security breach. Let's break down the vulnerabilities. It confirmed a SQL injection vulnerability because unsanitized input is passed directly into the database. The MySQL syntax error proves that an attacker could potentially read or delete the entire database. Second, there is information disclosure. The server is leaking its PHP and Nginx versions, which makes an attacker's job easier. There is also a potential risk of cross-site scripting, which we would need to test manually. The suggested testing steps include SQL injection, using order by and union select to extract the database structure and sensitive info, XSS testing, specific scripts in the URL to see if they execute in the browser. Recommend fixes practical steps to hide server versions and fix information disclosure. I gave the same prompt to Manus AI, and it analyzed the input to generate a professional penetration test report. This report details the findings of a penetration test conducted on an HTTP request and response provided by the user. The primary objective was to identify potential SQL injection, cross-site scripting vulnerabilities, and information disclosure issues. Based on that prompt, I asked for a follow-up exploring mitigation strategies for the identified vulnerabilities. This document outlines comprehensive mitigation strategies for SQL injection, cross-site scripting, and information disclosure. These recommendations are based on industry best practices to provide a robust defense against common web attacks. Core mitigation strategies. Implement. Parameterize queries to ensure user input is never executed as code. Use output. Encoding and a strong content security policy to prevent malicious scripts from running. Disable descriptive error messages, and hide server signatures from headers. I analyzed the same prompt using Claude AI for data analysis. SQL injection adding test equals query apostrophe to the URL triggered a database error. Lack of sanitization, the website sends user input directly to the database. Hackers could steal or delete the entire database. Information disclosure server exposes its name and version incorrect server configuration. Knowing the version allows hackers to find specific exploits for that software. Cross-site scripting is also present, and it's quite critical. However, our main focus here was SQL testing, so we crafted the query specifically for SQL injection. Based on that same captured request, we then analyzed other possible vulnerabilities as well. The key point is this: whenever you find a parameter, you can capture either a SQLi related request or an XSS related request and send it to AI for analysis. The AI will primarily focus on your main test case, but at the same time, it will also highlight other potential vulnerabilities related to that request. We also received information about potential XSS from the AI, so we are going to test that as well to see if the AI is actually correct. Let's check this out. I entered an XSS script into the search bar, which was actually provided by the AI itself. I've captured the request to show you. As soon as I forward this request, you'll see the XSS alert pop up. This is exactly what an XSS vulnerability looks like. Now, for a more thorough test, we need to send the request to the repeater. Find your target request in the HTTP history and send it over to the repeater. Here you can perform XSS penetration testing just like a pro. You'll be able to determine if your testing is successful directly through the server's response. I have organized the previous prompt by placing the copied request and response into their respective designated sections. This separate layout will make it much more convenient to use and analyze. I've submitted my prompt to Claude AI again, and it has officially confirmed the XSS vulnerability. It has also categorized the risk level as critical. Based on the previous SQL injection findings and the new request-response data provided in the prompt, the AI has now confirmed the XSS vulnerability as well. This means we have two critical vulnerabilities existing simultaneously. AI has provided a complete chain attack blueprint, just like a professional hacker would. It was laid out step-by-step testing methods, including bypass testing, escaping the query, data extraction, and automation for manual verification. I will provide the commands and guidance, but you must perform the actual testing. The AI acts as a specialized assistant. It does not directly scan or execute attacks on its own. If you ever get stuck on a specific command, the AI suggests exactly what to type. Finally, once the manual verification is complete, it provides the SQL map commands to automate the process and dump the entire database at once. I also ran the test through the Gemini CLI, and it has officially confirmed the XSS vulnerability as well. Just like the other AI models, it provided a structured breakdown of exactly how to perform the test. sgpt, an OpenAI model, is paid. Others AI free but limited use. Burp Suite Professional, more advanced tools. For learning purposes, the Community Edition is sufficient. However, when you are working for a company or hunting for major bug bounties, there is no substitute for the Professional Edition to save time. Professional Edition features automated vulnerability scanner. Simply by providing a URL, it automatically identifies SQLi, XSS, and all other bugs, then generates a comprehensive report. Using Burp Suite Professional and Burp GPT together takes penetration testing to the next level. It essentially combines your manual expertise with the intelligent analysis of AI. When you intercept traffic using Burp, it sends those requests and responses directly to the AI for deep security analysis. In today's world, AI has made our work significantly easier. If we have a basic understanding of ethical hacking and know how to use AI correctly, our work can reach a professional level. By leveraging AI's help, you can continuously improve your learning journey. For beginners, AI is exceptionally helpful. If you don't understand a specific topic, AI can explain it to you clearly. Using AI for learning ensures that if you get stuck somewhere, it provides an immediate solution. You don't have to wait for someone else's help. If you have any questions about today's topic, feel free to leave a comment below. If you found this video helpful, don't forget to like it and subscribe to the channel for more tutorials like this. Thanks for watching.